Very good morning and good evening to the participants who are attending it from other countries. I welcome all the eminent speakers and participants in today's session on AI Pe Charcha. As Barnali was saying that last year we hosted a big event which was attended by 150,000 participants across the globe. It was called the Responsible AI for Social Empowerment RAISE 2020. And the event was inaugurated by the Honorable Prime Minister of India, and where he called for making India as a global hub for AI. We brought together the policy makers, AI experts, thinkers, influencers, practitioners, and young minds, college students, university students from India and abroad at a common platform, and which could draw the attention of all these people on AI and focus related to AI technologies and for the social empowerment. This event, AI Pe Charcha, has been envisioned as a part of RAISE. RAISE will continue this year also, so we will be having a next version of RAISE this year. And we had a lot of sessions on AI Pe Charcha related to leadership sessions with esteemed government officers and industry AI experts. This initiative, which today we had a 7th episode, aims to explore the potential of AI enablement in health, agriculture, logistics, cybersecurity, infrastructure, urban and rural governance, to improve the citizen-centric services, leading to better ease of living of billion-plus population across globe. The today's session on AI Pe Charcha focuses on leveraging data, which is very, very important for AI towards social empowerment. We have some of the biggest program in the government. We have the biggest database like land record, where the ownership records are being maintained digitally. We have some other programs like employment guarantee scheme, where every day we have around 0.5 million transactions in a single program. So similar type of big programs are being done by Government of India and state governments. So this today's program will focus mainly on leveraging data for AI for social empowerment. And we have senior leaders, as Barnali was talking, from the government and AI experts from US and Philippines, who will share their experience on the latest advancement in AI and use cases related to India as well as other countries, and impact on social economic development. And participants will definitely get a global exposure on the best practices happening across the globe. And we will be taking a live queries also from the participants. So with that, I again welcome all the participants and the speakers for today's session on AI Pe Charcha. So I would like to call upon Saurabh Gaur sir, who looks after a very important portfolio of electronic manufacturing in MITI. And he also heads the AI and emerging technology group in Ministry of IT, and very actively working on our program, national program on AI. And with this, I request Saurabh Gaur sir to give his opening remark on this episode.
Thank you so much, Mr. Thakur, and my greetings to all the people who have taken out their time today to join from different parts of the world. I'll not take much time because there are lots of experts who will talk about different facets of leveraging data for AI towards social empowerment. But let me briefly talk about how do we in government look at the AI ecosystem in this very interconnected world, where the distinction between hardware and software has blurred to a great extent, and the fact that with the emergence of AI and the other artifacts related to AI or the other foundation technologies or into AI, we believe that with these capabilities, one can contribute to tackling all the issues around attainment of the all 17 UN Sustainable Development Goals, which can potentially help hundreds of millions of people in both advanced countries as well as emerging countries. India has a strong foundation to make use of these emerging technologies, in the sense that we have a very thriving Digital India program where we've been able to set some global benchmarks for leveraging technologies for inclusive growth, for good governance, and for empowerment. The Digital India backed by AI is our vision for Digital India 2.0, which is also going to be the future of e-governance in India, as well as the other aspects pertaining to digital economy. So with the advent of artificial intelligence, we are not just looking at an incremental change, but a paradigm shift in the way we handle things within the government and obviously outside government also, and utilize it for well-being of humanity at large also. If you look at India, and I'll talk about three pieces here. The first part being around data, and if you look at if data being the fuel for and the basic building block for any AI-related advancement, we have in India enormous amount of data getting generated from the 700 million plus internet subscribers, almost a billion plus mobile phone users, and with the fact that we have given digital identity to almost 1.3 billion Indians or people who are residing in India, that itself generates huge amount of data on a daily basis. As per the statistical research of 2020, in fact, across 3G and 4G networks in India, the data consumption also per user is almost 13 GB per month, which is, and also coupled with the fact that we have among the lowest data charges in the entire world. So what that amounts to is availability of lot of data. Now, how are we able to provide that as a fodder to AI ecosystem? In the national program on AI, we are envisaging a national data office to be set up, where we will make available data, open source data, and high value data sets which are amenable for usage by AI, along with providing models which can be utilized by the innovation ecosystem. So something what a Kaggle does specifically for India and Indian data purposes, building platforms such as this, and the fact that we already have a data sharing and accessibility policy. We are going to have legislation around sharing of personal data and some regulations around sharing of non-personal data, because of the fact that we really strongly believe in data sovereignty, and the fact that there has to be some oversight in terms of the way data is getting shared, and the fact that data pertaining to India should conform to data at rest, at motion, and in use it should conform to the sovereign principles. But having said that, that is not to take away the fact that there has to be very strong access to data to the ecosystem, and that is where we have set up the OpenGov data platform, which has almost 500,000 plus resources and almost 100,000 catalogs of data which are already available. So across federal government and state government, almost 177 departments have come together to populate this data. Obviously, there is a need to get more structured data and to provide services around labeling and structuring of data, and that is the part that National Data Office will be doing. The second thing I want to talk about is establishment of centers for transformational AI, and specifically in the field pertaining to inclusion, to social empowerment, in the fields such as health, where recently the Government of India announced National Digital Health Mission. Similarly, so where we look at data sets, high value data sets, whether they are around disease control or disease surveillance, or around availability of health infrastructure and services. So we are going to make available those kind of data sets. They are already available to a great extent in the public domain. There are issues pertaining to interoperability which are going to be sorted as part of the National Digital Health Mission. And but with very strong and robust norms for patient confidentiality and privacy, The health-related data is going to be provided through the National Digital Health Mission, and the Center for Transformational AI will be a plug-in to the Digital Health Mission. Similarly, we are looking at in education sector also the data sets pertaining to students and their learning outcomes. Similarly, the infrastructure availability in the schools, the class-wise, gender-wise details of schools, the other category-wise details of, in the sense that what kind of teacher availability is there, what kind of training is there. So all these is helping in predicting the school dropout rates. It is also helping in personalizing the learning journey and providing affordable solutions for learning, especially in this age when there has been a great amount of digital divide because of COVID and schools being shut down. So I believe very strong startups have come out, and in fact some of the biggest unicorns in India today are in the education sector, and we want to provide more access to big data in that sector also. Similarly, we can talk about numerous other examples in agriculture. We are getting commodity data, soil health data, and so on and so forth being made available through different portals and bringing them together. So what I'm saying is we are looking at a very exciting play of data and building use cases through the Centers for Transformational AI with a very strong involvement of the innovation ecosystem and the startups. The third one is the piece around ethical AI, where we believe that we need to be very conscious in terms of ensuring that bias is not built in the data sets. And as AI-based solutions permeate the way we live and the way we do businesses, there are bound to be questions on ethics, privacy, and security. And while being conscious of this, we are promoting the FAT framework, which is the Fairness, Accountability, and Transparency framework. And where we say that any document on promoting AI, we need to be conscious of the factors that may undermine ethical conduct, or they may impinge on one's privacy, or they undermine the security protocol. So ethics as a service is getting built in our system. Ethics councils are also going to be established wherever we are looking at in the Center for Transformational AI, so that solutions that are getting developed there are put to the test of ethics. So these are some of the things which are going to happen, and we definitely in India want to stake claim for leadership around these issues. And I am very confident of the fact that with a huge amount of skilling initiative that will also go along with this, the Indian ecosystem will respond to these challenges and will emerge on top. Thank you, Team NAGT, for giving me this opportunity.
And I want to extend my thanks to Mr. Vinay Thakur and Saurav Gar. Your comments were much appreciated, and also Abhishek Singh and the Ministry of Electronics and IT for inviting me. We at the Rockefeller Foundation are very proud of our engagement with the ministry through the University of Chicago's International Innovation Corps team supporting the National Program for AI and the Open Government Data Platform. Dialogues like this are a wonderful way to bridge knowledge and understanding between the public, private, and nonprofit sectors. I appreciate the leadership on these issues within the Indian government and that the previous speakers have exemplified. I understand that these are difficult times for everyone in India, and we at the Rockefeller Foundation have committed over $13.5 million to support India's fight against COVID over the last year. But I am also glad to see us discuss another key issue today around leveraging data and AI for social empowerment. For over 100 years, the Rockefeller Foundation has applied new technologies to advance our mission of promoting the well-being of people throughout the world. Data science, and more recently, the application of AI and machine learning tools serve as the current iteration of that unchanged mission. We think about data science in two ways. So first, as a capability that enables us to accelerate the impact of our other programmatic work in health, food, energy access, and economic opportunity. And then second, we see artificial intelligence as transforming the very fabric of our lives. When the foundation funded the Dartmouth Summer Research Project in 1956, it was a gathering of renowned scientists, engineers, and mathematicians, and they came up with the term artificial intelligence. The concepts driving AI were so new that their implications were understood only by the innovators who were developing them. Today, with further development and integration into society, AI's impact on our lives is much more consequential. The current pandemic is accelerating AI's integration into nearly every aspect of our lives. How we manage AI's role in addressing the crisis and managing our recovery will undoubtedly define the next era. As we reimagine a way forward, the Rockefeller Foundation is betting that AI will help rebalance and reset the future in a way that addresses current inequities. In October of 2019, the Rockefeller Foundation convened an exceptional group of technologists, philosophers, economists, lawyers, artists, and other philanthropists at its Bellagio Center in Italy to discuss AI's role in creating a better future for humanity. One of the conclusions of that group was to realize that in order to realize AI's potential for positive influence, we have to accelerate progress on AI governance. And in early 2020, we launched a report, AI +1 Shaping Our Integrated Future, which captured some of the ideas from that convening, including an emerging consensus on the need for AI governance. But we believe we must move beyond the high-level principles and ethical guidelines towards new ideas, new solutions, and new practices. With the launch of the AI +1 report was an important step towards understanding what is needed and what it will take to get there. The Foundation is working on a number of solutions to meet the challenges we're currently faced with. One hallmark of the Rockefeller Foundation's approach to realizing impact at scale is to be constantly innovating, testing ideas in practice, sharing lessons, and striving for continuous improvement. We play a bridging role in applying science and technology to social challenges. We are connected to researchers and innovators in academia, government, and the private sector who have compelling ideas, but don't always know how to develop them from application and where to best deploy them. At the same time, we're connected to development agencies and civil society and government who have a deep understanding of the root causes of important systems challenges and are eager for solutions. It's from that perspective that we learn about how AI can have meaningful impact on important social challenges, rather than how AI can be used in the most interesting way. Based on that perspective and lots of work in applying AI to social challenges, let me share the Foundation's experience and propose 5 insights that guide our approach for building responsible AI for social empowerment. Number 1, good AI requires great data, and the previous speakers touched on this. The real challenge of building human-centered AI goes beyond how the algorithms are designed, storage infrastructure, or computing resources. It lies in the access to accurate, reliable, and timely data, and ensuring this access is continuous. Data availability determines what problems are worked on and what populations are served. Thus, an enabling ecosystem should strive to provide access to such data from government and non-government sources, including data from the communities themselves. An instance of how we are working to propel AI-driven innovations by increasing the value of machine learning tools for the poor and vulnerable is the Lacuna Fund, which my colleague Evan oversees. In partnership with Google.org and Canada's International Development Research Centre, the Foundation incubated the Lacuna Fund to finance the creation, expansion, and maintenance of labeled, localized data sets, beginning with a focus on agriculture, language, and health. It is the world's first collaborative effort to provide data scientists, researchers, and social entrepreneurs in low and middle income communities with the resources they need to produce labeled data sets and build AI applications that benefit farmers, community health workers, and local entrepreneurs. We've started this work in Africa, the region most often out of the global machine learning databases, and we're planning to expand our dataset funding to research communities in Asia and especially India soon. Insight number 2, unlocking novel insights to support many applications. Strikingly, 90% of the data ever generated by humans in any form has been created in the last 2 years. By some estimates, less than 1% of data generated is ever analyzed, largely because humans have a finite capacity to absorb and use information. We have to be intentional about translating the latest science into useful insights. The Rockefeller Foundation works with leading academic research teams to help them translate their cutting-edge research into impactful tools. One recent example is Atlas AI, a startup founded by Stanford University researchers to provide economic and agronomic intelligence for emerging markets. With new precise insights into plot-level crop yields, household wealth and consumption, and more, they can support a whole host of practical needs of financial service providers, agribusinesses, governments, and other organizations operating in data-sparse environments. It helps them overcome the perceived risks of serving markets that benefit poor or vulnerable people by adding precision to the planning, managing, and monitoring of investments that can generate both social and financial returns. Atlas AI has already applied its insights to problems ranging from the near-term distribution of vaccines to the long-term development of energy infrastructure. Insight number 3, overcoming important bottlenecks. For decades now, we have seen the private sector use data and data analytics, such as artificial intelligence, to improve productivity and market impact. However, most nonprofit, civic, and public sector institutions have not been able to optimize the power of data in the same way. Often it's because the potential for AI's ability to enhance impact isn't done with full consideration of the political, social, cultural context in which we expect users to apply these tools. For example, take the issue of lead pipes delivering water to homes, and we're joined by Eric Schwartz, who's been leading this work. Among many problems, the lead in the water causes health and educational challenges for children. It's not only an infrastructure problem, but it's also a political and racial justice problem here in the United States. And Blue Conduit has been a leader that we've been proud to partner with. They use existing construction records to feed machine learning tools and develop very accurate inventory of lead service lines in US cities with a high risk of lead exposure. In decreasing the uncertainty about where these lead service lines are, cities can prioritize replacement efforts at much less cost. Blue Conduit's predictive mapping algorithm has achieved 70% accuracy in locating these toxic lead pipes for removal, compared to only 14% accuracy using more conventional methods. That's a 5-fold improvement. Key to their success, however, is deep engagement with communities, local governments, and nonprofit organizations to ensure that the insights generated by their tools would lead to awareness, beliefs, and behavior changes so that all actors could coordinate to realize the potential of those insights. Now, insight number 4, building capacity in civil society partners. To build a data-savvy future leadership and governance ecosystem, we are also engaging with the next generation of governance and civil society leaders through accelerated learning programs with the United Nations Development Program and Asian Ventures Philanthropy Network in Asia and India specifically. Our goal is to empower public sector agents of change and to increase the state's capacity in executing and achieving impact goals. Under NextGen Gov, both Rockefeller and UNDP are working together to support champion policymakers of Asia embarking on a learning by doing journey on the future of governance. In the Philippines, along with the UNDP's Regional Innovation Center, we have launched the PINTIG Lab, which means heartbeat in Filipino, to harness data innovation for the country's socioeconomic health in response to the government's COVID-19 amelioration program, working closely with multiple ministries. We are also excited by the work of Data.org. Data.org is an organization co-funded by the MasterCard Center for Inclusive Growth and the Rockefeller Foundation to build the field of data science for social impact. Data.org supports compelling use cases to inspire others, build capacity through new talent and organizational capability, and developing commons and public goods that can be used by everyone. In 2020, they ran the Inclusive Growth and Recovery Challenge that awarded $10 million to winning organizations who proposed the use of data science to improve and scale their impact. From over 1,000 applications from over 100 countries, 8 were selected and are now using data science and building their organizational capacity. One of the winners, BASE, is focused on the problem of moving food through the cold chain here in India. They are building an open access mobile application using mobile learning that will enable smallholder farmers to access clean and efficient cooling and expertise in pre- and post-harvest management. Smallholder incomes are expected to increase by 10 to 30% per year, while also reducing greenhouse gas emissions and improving food security. Last but not least, insight number 5, AI governance as a foundation for scaling applications. As AI-related technologies penetrate even more aspects of society, the management of AI will be a societal challenge as well as a technical one. If left unchecked, AI technologies can ignore human rules and norms, diminish privacy, and manipulate or addict people, promote the spread of disinformation and group polarization, and amplify societal biases. At the same time, we can harness AI technologies to improve healthcare, government operations, scientific research, and confront such global challenges as the COVID-19 pandemic and climate change. In collaboration with the Schwartz-Reisman Institute for Technology and Society at the University of Toronto in Canada, and the Center for Advanced Study in the Behavioral Sciences at Stanford University here in the US, the Rockefeller Foundation has been facilitating a series of convenings to explore issues related to the future of governance of AI and to shape concrete prototype projects. As we've grown this community of experts and leaders over the past 2 years, we now seek to collaborate with a broader global dialogues in order to articulate, prioritize, and lead execution of a set of collaborative prototype projects intended to drive the development and implementation of new AI governance approaches. Thank you so much for providing me with the opportunity to share some of our learnings and experiences with the ministries and departments represented here today. My team and I would be happy to engage further in cross-learning sessions, as well as facilitate across tools, platforms, and case studies to support the government's efforts in deriving value from data and advanced technologies for the benefit of all. Thank you very much.
Thank you so much. Thank you very much, everyone. And thank you to the ministry and the host today for inviting me and Blue Conduit. As said, I'm co-founder of Blue Conduit and also an associate professor at the University of Michigan, the Ross School of Business. As part of Blue Conduit, we have partnered with the Rockefeller Foundation. So Zia and Evan and Priyank, thank you very much for the partnership. And I think you'll hear a lot of the same themes that Zia has just mentioned in the short presentation that I will provide as well. I would like to begin by saying is Blue Conduit is a spin out of the University of Michigan that is a data science for social good, public health, social venture, where we are using data to bring clarity to service line, the lead pipes in the ground nationwide. The reason that we're going to turn to AI for social good and improving public health is fundamentally, we believe that all cities and communities should be able to replace any hazardous infrastructure that exists. And you'll see that the AI machine learning technology that we've developed is based on this social mission. And Blue Conduit is founded 2 years ago to help cities do just that. We've started by using statistical machine learning to help identify and replace the lead pipes throughout the country, but that's just our first, and we will be going elsewhere to other domains. But let me just start with these lead pipes. So what does it mean to devise an ML algorithm to find and accelerate the removal of lead pipes? Well, first, we are now doing that in over 50 different communities and towns across North America. That is covering over 500,000 pipes and over 1 million people, saving a cumulative over $20 million in largely taxpayer money or ratepayer money. And it started with the very prominent case and really tragedy in Flint, Michigan, the Flint water crisis that some of you may be familiar with, that really began in earlier on 2014, when community in Flint, Michigan, just 1 hour from where I am, where we're based here in Ann Arbor, Michigan, had lead contamination across their city. Now, part of what we do is to facilitate government transparency and empower communities by providing information through maps and validated reports. And also I heard earlier mentioned bias and the importance of bias in data. And one factor that we really spend a lot of time working on is reducing bias through representativeness and striving for equity in the work that we do. And finally, all of the work that we've been doing is based on rigorous academic research that we've published, research that we continue to pursue and continue to actually intend on making much of it open source for the rest of the world and the community. And these lead pipes are a large problem nationwide. I say nationwide, this is North America, Canada as well. There's 6 to 10 in the US. And we are now seeing not just regulatory change in our main regulatory body, the EPA, but also President Biden and Vice President Harris are talking in the past just recent weeks and months about replacing 100% of America's lead pipes and service lines. That's these that we're talking about. India recently has had some concern expressed about ignoring the lead that is seeping into its tap water. So whether it's the faucets that are made of brass and lead, or the pipes that are entirely made of lead, or pieces of lead left in those pipes, we are concerned about finding those. The issue is cities don't know exactly where the lead is. This is the large challenge. This is the uncertainty. You can see the lead service lines that we refer to are these red tubes that are going from the street perpendicular into the home. But the actual records that exist, if they exist, are largely handwritten or old, not representative data. It's expensive to verify these pipe materials. There's no outside detection mechanism. You need to dig, and that's costly. And once you find out the material of the pipe, then you need to replace it, and that's costlier. And so this high cost puts a burden not just on all communities, but disproportionately on communities that are under-resourced, disproportionately on communities that have historically been marginalized by the systems that have generated the situation we're in. So this is, as I mentioned, an economic justice and political and social concern. So I'll use quickly to review what we've done in Flint, Michigan, but really this extends to the communities that we've worked with the Rockefeller Foundation, that's Toledo, Ohio, Newark, Trenton, New Jersey, Benton Harbor, Michigan, as well as now continuing to expand that work now into Detroit, Michigan, and beyond. The key is, and this works everywhere, early on, we don't really know. We see a lot of question marks. The goal is to not just predict, but also decide what the best data set should be. How can we actively collect data in a representative fashion so that we can best inform the AI system to best let the statistical machine learning do what we know it's best doing, which is use representative data to make predictions on that broader population. And so you can see as the colors go here, we want to turn those gray houses into shades of green and orange so that we can then best rank the homes that have the highest chance of being lead, or orange in this case, and prioritize and provide a list to the local government to go dig where the lead is. And that's exactly what we've done. So the city of Flint has done this, and each of these communities is on the path to doing that as well, where we're directing where they're going to inspect, gathering data, and then directing much broader programs to send crews so that they don't have to dig and then find there was no lead, but they can use their resources efficiently. And this statistical modeling is driving the decision making. And you can see the predictions are actually not immediately intuitive sometimes. Homes right next to each other can have vastly different probabilities of having lead. And so it raises the question that a lot of our heuristic ideas that this neighborhood has lead, this neighborhood doesn't, or houses built before this date have lead and all after this point do not, are not enough. That the heuristics are just that we need a more complex, a richer story with statistical and machine learning modeling to really maximize the public health impact per dollar spent. And again, by digging where the lead is, we can reduce that uncertainty in these gray areas into shades of green and orange, to then reduce even the orange over time by replacing that and guiding the community's own replacement. And how it works is really we're predicting unknowns. So it's as simple as here's the data set, a stylized data set where we don't know the material on the far left, And we're trying to fill in the blanks with probabilities and risk scores. And from there, we can then show, well, actually, it performs quite well. Don't need to get into the details, but the evidence is there that when you're digging where the lead largely is likely to be, you are having a very high hit rate where you're using these funds for every attempt of digging, you are taking out lead at a higher rate, 70, 80, 90% in some cases, as you can see across these 4 different communities. But beyond just the simple dollar savings, beyond the direct public health benefits of reducing time that people are living with lead, we also really value the importance of transparency and public communication to empower individuals. And I think one of the themes of this convening here is to empower communities, empower individuals, and that aligns exactly with our values and what we've been practicing. So by developing not just a publicly available list of houses or a public map, but really working with public health experts as we have here to develop with communities and in a co-creation fashion, what do you need? What do the communities that are concerned about lead need? And what is the appropriate public health communication to provide? And how can we make that communication actionable so people aren't just being told you are living with lead or a high probability of lead, but in fact, here's what you can do about it. Here's who you can call, here's where to get a filter, here's where to get free water testing and free filters, etc. And really the broader ideas around this, that this is not just about AI and machine learning, it truly is about the values of providing accurate information to the decision makers, to provide actionable data and information to those decision makers, and finally to foster the stakeholder trust in the system. A lot of the concern that grew out of Flint and many of the other communities was an existing distrust of the government. And when you find out that your government has in fact told you your water was safe when it in fact was not, that trust is even further eroded. And so it takes quite a lot to build that back up and support that empowering of individuals and communities. And the impact here is, in the opportunity in the United States alone, is quite massive. These are some of the communities that we've now partnered with, thanks to the Rockefeller Foundation, but the broader opportunity is large. What President Biden and Vice President Harris are proposing is a $45 billion project, an estimated cost. And by working not just with the cities and states to do this, but to really engage communities genuinely is going to be the right path to do this. And I think as I see very quickly, a quick question from Dr. Malhotra, indeed that I've presented it in the simple way of as if it were a regression, but a simple regression actually fails to capture many of the complex relationships between the many factors, like the age of the home and the existence of records and the existence of other water testing information and really hundreds of possible variables that interact. And the importance here of machine learning is to really open up to all possible variables and get a prediction, in addition to how do we directly optimize the decision making. One thing I haven't spent the time here to do, but I'm happy to answer or follow up with anyone, is really that part of the broader system here is optimizing data collection and decision making, not stopping with just a prediction.
Good evening to everyone. Thank you, Sir Thakur, and the organizers for this opportunity to share with you work that we did at the Pintig Lab at the UNDP Philippines with our partners, Thinking Machines and Zero Extreme Poverty Philippines 2030, on understanding poverty through mapping in the Philippines with AI. To put it into context, know that around 20% of Filipinos live below the poverty line set by the World Bank, and this is expected to increase now due to COVID-19 crisis. And eradicating extreme poverty is one of the country's and the world's greatest challenges, and one of the 17 Sustainable Development Goals that UN aims to achieve within the next decade. And many international and humanitarian organizations working with the government are doing interventions to uplift families from extreme poverty. And one of the challenges is in identifying the locations of the most vulnerable communities and connecting them with organizations that can be most effective in making an impact. The usual way this is done is to conduct household surveys, but wide coverage surveys like these are expensive and time-consuming, and even more challenging now in the time of pandemic. So the goal of this project is to use machine learning to augment these surveys by filling in the data gaps in areas which have not yet been surveyed. So in a way, it's similar to the use case that Eric showed earlier. You have information that you know, but there are gaps and you want to fill them in. And machine learning is a effective way, powerful way to do just that. And the output that you get is a high-resolution map of poverty index over the country that can be used to target humanitarian aid, target interventions as well, depending on the access that's needed in the communities, and also opens up many possibilities for cross-analysis overlaying with other risks and hazards, for example, COVID risk and natural hazards that beset the country year in and year out. So we'll share about this, the methodology of the project. As a background, in the past few years, there have actually been a lot of solutions using high-resolution satellite imagery and machine learning, in particular deep learning techniques to predict poverty. And this has been done in many different countries. But the cost of high-resolution images can be a barrier in implementing these for low-resource organizations, and also the black box nature of deep learning makes the interpretability and transparency of the results means that they can be improved. So in this project, we pursued a novel approach where we combine publicly available geospatial data sets and feed them in a relatively straightforward machine learning model for an interpretable solution to poverty mapping. So the data includes low-resolution features from low-resolution satellite images, as well as social media data and points of interest data from open source data sets. For the ground truth on the wealth, on the poverty index, or in this case, the key variable of interest is wealth index. It comes from National Demographic and Health Survey conducted by the Philippine Statistical Agency. And they capture a number of socioeconomic indicators related to asset ownership, education, health, sanitation, and hygiene. In particular, the wealth index is a composite index that combines these and measures a household's cumulative living standards based on asset ownership, the materials their house is made of, the roofs and the walls, as well as their access to socioeconomic assets. So there are over 1,000 household clusters across the country that have been survey here. So the model, trying out different methodologies, found that the random forest regression model works the best in predicting these socioeconomic indicators based on this publicly available data. So in particular, we have three kinds from the satellite images. We have features on nighttime lights, NDVI, the vegetation index, and land surface temperature. From Facebook Marketing API, we get the percentage of households with 4G, 3G, or 2G Wi-Fi connection, as well as the device, the brand of the device, and consumer preferences. And finally, we have points of interest data from OpenStreetMap, as well as Check My School, which is a local platform that maps out where the public schools are and their level of access to resources, as well as Department of Health registry data for the mapping of hospitals and healthcare facilities in different areas. So putting all of this data together, we find that you get a better model, the best model, by combining all three data sources, as you see in the table here, versus just having POI data only, or remote sensing data only, or social media data only. But together, you get the best model that can explain 66% of the variance in the wealth index. For comparison, a deep learning model based on high-resolution images for the Philippines in a previous study achieved an R-squared of 0.63, which is actually comparable and even improved on that methodology with low cost and very accessible data sets. So the chart here shows the predicted wealth index versus the actual wealth index, and we see the relationship here, of course, with some scatter. But overall, as you can see in the maps here, the estimated wealth matches well with the actual values on the right, and does it with 18 square kilometer granularity. Of course, we also note that the model does not do as well in capturing the most extreme values, so the most red and the most green regions here. Looking at other socioeconomic indicators, we find that the model does well in predicting some. So in particular, the proportion of households with toilet located outside has also good R-squared performance, and this could be a signal for open defecation. But the model does not do as well in predicting other socioeconomic indicators such as clean water source or educational attainment. So this is still a challenge. But by and large, we can use not only the wealth index, but also the features that are used by the model to really profile the different areas and communities in the Philippines. So just as an illustration, we show here two areas. On the right is Marikina City in the capital of Metro Manila, and we see it has a relatively much higher wealth than an area in the rural area in the island of Palawan. And in addition to the wealth index, we can see in terms of the number of banks, number of restaurants, and the proportion of the population with 4G access, we see that there's a large discrepancy between these two areas, and that's driving also, or that's really what's driving the wealth index predictions in the model. So this makes the model highly interpretable and transparent. Now, looking at the most relevant features, so the features, the input variables that have the most impact to the model, we used the Shapley additive explanations, or SHAP open source library that to get to measure the value or the impact of the different features, and find that the ones with the biggest impact are actually the nighttime lights and the proportion of population with 4G access, as well as the percentage of schools with water values, with water. And they contribute up to 10,000 wealth index points from the average. The chart here shows the variance in the wealth index when the particular variable is added to the model. So the larger this variance is, means that the particular feature has a bigger impact in the model. And the correlations also are as expected. So brighter areas and higher percentage of 4G users and schools with water indicate a higher wealth. And in terms of the limitations of the study, it comes mainly due to the limitations of the data that is used. So in particular, the completeness of data in the Philippines and other countries is not uniform. And for example, in this map shows the OSM data incompleteness over the country. So in places like Metro Manila and neighboring cities, you have a higher completeness, but in as you go out, this becomes also less wide coverage. Another challenge is the difficulty to predict other socioeconomic indicators, and one way to address this is to get access to other representative surveys done at the national level, but also granular in scale. Again, there are resource barriers here, but hopefully as we get more appreciation of the value of data and the ability to augment these traditional data sets with non-traditional data sets and with AI and models, we can accelerate these data innovations as well. So to sum up, we try to answer the question, can we use unconventional data sources to infer socioeconomic indicators? And we find that yes, there's a relatively low cost and the interpretable and transparent method that can give these insights for people who will use them. And we at the Pintig Lab are continuing to develop these initiatives and expand to really demonstrate the potential of these non-traditional data sets and data science and AI models to inform decision making, not only within development organizations but also in the national and local governments, and also open these up to civil society and academic researchers, so that different stakeholders will be able to work together towards achieving our sustainable development goals. So again, thank you so much for the opportunity And I leave here my contacts for anyone who would be interested to learn more or to collaborate.
Thank you so much, and thank you again to the ministry for such kind words in the beginning and hosting the panel. It's been great to hear from the other panelists. It's always inspiring to hear about their work, even though I know it quite well. It's great to hear it presented in this context. My name is Evan Toski. As mentioned, I'm a director and lead data scientist at the Rockefeller Foundation. That means that, in my day job, I will both be building models using data, and then also advising on the funding and structures around those models. And so one of the things that we've been working on for the last couple of years is a new fund called Lacuna Fund. And Lacuna Fund, in brief, is a fund for machine learning data sets of high social value around the world. I'm going to explain today a little bit about why Lacuna Fund matters for us at the foundation, how we've built it, and how we propose to expand it over the next couple of years. So first, the premise, I know we have a lot of technical people on the call today, so I probably don't need to belabor this point, but artificial intelligence is nothing without data, right? The process of artificial intelligence is either learning from or optimizing a sort of search across data sets. But therein lies the problem. A lot of the bias we see in the world, a lot of the problems we see with, when there's a headline that says algorithm fails to work for this social group, or there's bias in this way or that way, it's really rooted in this data collection process, the curation process, and then sometimes in the release process, so who actually can get access to those data sets. This is something at the foundation, we've seen over and over again in our work. We have a great opportunity to collaborate and fund projects like the one you heard earlier today. And so we see, the social innovators, the researchers who are building these sorts of things. But despite incredible progress and some of the incredible work we heard about today, there still are so many blockers and so many potential unrealized opportunities from AI. And this is, where we feel data sets come in. To put a finer point on it, research from some folks at Facebook in 2017, they looked at the two biggest open image data sets. So open images from Google, and then of course the classic ImageNet. And they found that 60% of the images in those data sets, these are the real fundament, the tool we pick up whenever we want to pre-train a sort of image model for a whole bunch of tasks, come from just 6 countries. And the majority that you can see on this map come from the US, Canada, and the UK, right? That leaves out massive swaths of the population around the world. Their images, what their things look like. I think one of the examples they use in the paper is a wedding ceremony, and whether an algorithm can detect whether you have a bride and groom participating in a wedding ceremony. And performance on that, relatively simple task in the US is quite high. But around the world, many people get married around the world, but the computer can't understand that as a marriage or a wedding because they're left out of these sort of large data sets. As we get towards more emerging uses, so we've had image detection for years, but as we get to emerging uses in healthcare, for example, we find the same pattern and even more acute. So a recent study focused by the folks out at the Stanford HAI Center found that 71% of the data used in clinical AI applications, these are the ones that are actually deployed and have been used for clinical use, the data comes from just 3 states in the United States. So now we're not even talking globally, we're saying 3 states. And then the paper doesn't fully quantify this, but when you look at it, it's really 3 geographic areas. It's the New York City area, it's the area around Boston, and it's the area around the Bay Area in California. And of course, this makes sense when we think about great research hospitals are in those areas. But it doesn't make any sense when we think about, say in the US context, all of the people who live in Texas, or all the people who live in Florida, or all the people who live where I'm from in Ohio. And all of those places have great hospitals, but none of these sort of samples are ending up in our machine learning data sets. And so of course, while that gives us something that we can use, it exposes us to potential errors that we might not be able to see. Medical practitioners who have to come to trust these tools to assist in diagnosis, they're not going to have time to read sort of every paper about every origin of every data set. And so you create this real risk that we're putting out tools that we don't fully understand and that aren't fully representative of our communities. We've seen this for a while. So across the foundation's work, we work in the US, projects like the one Eric described. We also work across Africa, Latin America, and Asia. And so this problem has been consistent. And when we see a problem that's consistent enough, we say, okay, we need to step back from funding individual projects. This isn't just about finding one team to fund one data set one time. We need to think about an institution. We need to think about something that's going to bring in other funders, that's going to allow us to collaborate with governments, allow us to collaborate with a lot of folks at once. And so we decided to set up the Lacuna Fund to support the creation, expansion, and maintenance of these equitably labeled data sets. Lacuna means a gap in a manuscript, right? And we felt that was a really telling or useful brand to explain. We're essentially see this global manuscript, the global corpus of information we're feeding into AI models, but we have these massive gaps, massive chunks of humanity, and even then within countries, populations are left out of these data sets. And so the goal of Lacuna Fund ultimately is to fill those gaps. We set it up in a slightly different way. So often at the foundation, we take in projects, we evaluate them, make a funding decision, and kind of go forward. For this, we set up 3 levels of governance, and we found this is critical because we wanted to empower the level of governance all the way on the right. So the technical advisory panels are where a lot of the work happens. Those are researchers from communities that are affected, right? So if we're going to do an agricultural call in sub-Saharan Africa, the technical advisory panel will be made up of experts from that community. They help us identify the specific tasks that we're going to fund around. They develop the language around that so it's clear to their communities. They set priorities in terms of how things will be graded, which projects will get more sort of weight in the overall proposal. And then they're responsible for the review process to advise on the selection of those proposals. We of course have more traditional parts of this, so a secretariat that manages the funding, pulls money from different funders, brings it all together, manages the back office. And we have a steering committee made up of global AI experts as well. But really, we wanted to put the weight on this technical advisory panel because we were finding that the real problem is, in addition to not having any data sets, many research communities around the world weren't empowered to even create their own data sets. They couldn't get the funding to do so direct from other philanthropies or through other funding sources. And so we wanted to really empower that side and then push, as you see here, the funders to the bottom. So while we have great appreciation for our colleagues at IDRC, Google.org, and Fair Forward, and GIZ, the German government, and others to announce soon, we're very grateful, but we want to be clear that this is supposed to be technically driven and research community driven instead of funder driven as a long-term institution. So since we started work on researching this in January 2022, we've been able to make significant progress. We've raised just about $5 million, reviewed over 230 dataset proposals, and we funded 16 projects so far, focused on agriculture and languages across sub-Saharan Africa. We'll have more announcements to come, and then the exciting thing that we're working on this summer and this fall is expanding to go global. So we're going to launch a call for health data sets, looking specifically for biases in diagnostic tools. And that will be open to researchers around the world to apply. And then we're working now on developing a data set call around climate and power systems and energy systems. And we hope that will also be global. And this has been, as far as a project we fund, I think we often get really excited about products, right? So the stuff that, say, the Blue Conduit team is producing is absolutely essential. It drives just these significant improvements in the quality of the water that people are drinking, etc. And that's really exciting, but we've also tried to keep our pace with some projects that are more infrastructure, some projects that themselves represent the sort of basis of other research and other work. And so it's been very exciting that we've been able to get other funders to join us in this. I think we thought at the beginning maybe this might be something we'd have to do alone, but we've had eager sort of interest, and I think others have come to sort of appreciate and see that really this sort of data set lever and the infrastructure around data sets is critical for our future together working with AI. 2 examples. So the first example here from our natural language processing call, we funded a project on named entity recognition across, I believe, ultimately 11 languages across Africa. And so for those who maybe aren't in the NLP community, named entity recognition is basically training computers to identify certain types of entities. So these could be names of people, dates, locations, in a given corpus. This is really essential if we want to figure out anything about how these things interact with each other, right? If we want to understand, say for applications and symptom detection, that there was a certain symptom at a certain time in a certain geography, and we want to be able to reliably extract that from text messages, from community health worker notes, from hospital notes, from news reports, etc. To be able to do that reliably, gives us much more foresight on where there might be emerging clusters of symptoms in certain communities. And before, it wasn't reliably possible in many of these languages that we see here, despite the fact that many of these languages, so Swahili, Wolof, Igbo, these are languages with massive populations speaking them around the world as their primary language, and many professionals working in these languages. And so the team at Masakane, which is a Pan-African natural language processing community, came together and said, we want to build data sets to improve this task. And so one of their projects was funded by Lacuna Fund to build out these named entity recognition data sets across the languages you see below. A second project that we're really excited about and is illustrative of what Lacuna Fund seeks to do from our agriculture portfolio, the team at Makerere University in Kampala, we've given them funding to expand the imagery and spectrometry data sets they have for detecting pest and crop. And so this is a team, been working on this for years and are quite expert in a number of different pests and a number of different maladies that affect staple crops across sub-Saharan Africa. And they've done great work. They've shown that they can get models that perform very well. They get models that perform very well in challenging scenarios, so putting them on low-powered smartphones and giving them to farmers and extension workers, etc. But what they were finding was they were having problems with sort of geographic expansion, and then there's always more you can do in terms of improving the accuracy or specificity of the models you're doing. And so we provided this team with additional funding, and then those data sets will both be useful for their research and then also be open source so that others, right, say within governments across East Africa, that they'll be able to use these data sets to build tools for their extension workers, for their farming communities. During funding Lacuna Fund, creating it, developing it, I think we've learned something about the process of funding data sets and the process of supporting these data sets. I think the first one, we have a sort of phrase where I come from, and it's, is the hike worth the view? And I think that's always the question to ask about a given data set. Are the tasks that are going to be enabled by this data set ones of high social significance, or are they purely of maybe academic significance? And while we shouldn't exclude the ones that are just of academic significance, we need to prioritize them differently when we have such pressing social needs, right? And so when it comes down to it, I want to identify what's the connection between a given data set and food security across East Africa. How does this data set, over the course of years and over the course of a lot of other steps with research communities developing things, result in things that actually will save lives, result in models that actually will guide government decision makings in real high stakes scenarios, right? So we're removing significant money, removing significant choices. And I think it can be very hard to think about, because often when we're thinking about these data sets, we're at the start of that process and we're at the very fundament, and we don't know exactly who those others who are going to build on the data set will be. But we have to at least have that vision before we can go out and fund a data set. Second, data sets should be guided by research communities, and especially here, it's important to think about emerging researchers. So I think in our work, we have of course relied on and benefited from greatly from senior faculty members and others who are deep experts in the field. But we've also found that younger researchers, because they are trying to make a name for themselves, because they are trying to kind of forge new areas of research, are especially helpful in thinking about and coming up with the ideas for what data sets should be done. And so we've had great collaborations across our work in Africa with a group called Deep Learning in Daba, which is a large conference and also community, and then the Masakane community that comes around natural language processing. And I think connecting with these communities, harnessing their energy and allowing them to kind of lead and set the agenda, while of course providing the insight and guidance from more senior researchers, has been part of the success of Lacuna Fund. And then third, and this comes as no surprise to all of us on this call. I think there are collaborators. This is a group of collaborators, right? We're all interested in the sort of intersection of government and research and private sector here. But it's absolutely essential to have all three of these sort of expertises, so the machine learning domain expertise, the domain expertise, and then the expertise of those who hold or are responsible for keeping the data, to be represented in these proposals, right? And so we found that compared to normal projects where it might be one team building one product in a very sort of tight managed way, when we fund things, under Lacuna Fund, it's a really wide range of collaborators. There could be multiple sort of subawardees and partners and multiple government partners and, domain experts, that maybe don't have machine learning expertise, may not be the traditional sort of experts in that area, but, are essential for understanding how data is produced and how it's done effectively. And so we want to be open to that collaboration and actually want to incentivize that collaboration as the sort of fuel for getting it right, for getting the selection of where we fund data sets right, for getting the selection of the individual data sets, and then ultimately making sure those data sets connect with the research communities that are going to turn them into products and tools for social impact. So with that, I'll wrap up my remarks, and thank you all for your patience and attention, and really excited to engage with the questions in the question and answer session. Thank you.
We see AI in terms of, in fact, the use cases we saw that were demonstrated today. But suppose if you are looking at qualifying for government programs also, we are looking at better targeting for social empowerment, for social inclusion, better targeting of beneficiaries for selection of entitlement programs. When we look at launching the programs in social sector, be it in education or health or pension schemes or so on and so forth. Similarly, in terms of the other entitlements for food subsidies and all also can be better targeted. We saw the presentation from Philippines also, where the socio-economic status of people can also be, through using satellite imagery and other things, they can be better predicted. So I believe there are huge amount of use cases. Similarly, for example, state governments have come out with great programs where they are able to, for example, for pensioners, they're able to do recognition of people and simplify their processes in terms of giving them their social welfare pensions. Similarly, in employment generation schemes also, I believe there are instances of plenty where AI and machine learning has been used to better target programs related to microfinance, related to giving subsidies for generating livelihoods and so on and so forth. So I believe every facet of our life, there is an application of AI that can touch it and make it a better place for us.
Yes, absolutely. And I actually answered in the Q&A. I provided the citation, the URL, the open access PDF, and a nice little video about it. And for those folks who are looking for more technical answers, apologies. I didn't want to get too far into the random forest and the extreme gradient boosted trees. But the beyond prediction is really looking at active learning methods. How do you decide which data points to sample from a possible set of data points, and how do you decide which ones to pay to collect? So in the relating a lot to some of the challenges that Evan pointed out in the Lacuna Fund. How do you deal with the bias from that data collection? How do you ensure that you're not going to propagate that bias? Bottom line is it has been as low as about 5% or 10%, but rarely higher than 30, almost always lower than 25 or 30%. And I say that with some range, one, because we have a lot of different communities and different data sets. So if anyone kind of gives you one single answer all the time to every model, that probably isn't the true error of any one application. But really, we're looking at two different errors. One would be the area under the ROC curve for relative rank ordering of these homes. And the other is really not a model issue. It's really the decision. How good was the decision? So the question isn't just how good is the model, but how many homes did we say go to? And how many of those, how many did they find lead? That at the end of the day is the thing that's going to drive cost and drive public health. So that's the numbers that are in the 70 to 90% range. the first step, I think, is really knowing who the key decision makers are, and who are the people that are either, as Evan pointed out, kind of who controls the data, who knows the problem, and I think then the question is really asking what data exists, and being able to get that. And to the third is how might you begin thinking about gathering a representative sample to build a data set that would be unbiased and give a picture of what is going on. Again, all of those things I'm saying before needing to build any sort of fancy machine learning architecture.
For this initial model, it was not, I would say that the main criteria for choosing the data sets were the availability and the cost. So the satellite images have the power that you have it nationwide, and at relatively low cost you can get these features that are we know correlate with wealth index. So it started from that kind of thinking. But as we explore further use cases for this, and as we envision this feeding into decisions on programming and prioritizing projects and budgeting and investment for different communities, we certainly plan to involve more stakeholders and consult with them, so that we can have richer inputs also on the gaps and the biases that are involved in the process. So that includes civil society organizations as well as communities themselves.
This will be the next 10 years of figuring it out. So, if anyone has a head start on that, it'd be great for them to share. But, my sense is that it's less about control and it's more about consideration of trade-offs. So there is no sort of perfect process here, but we have to ensure that everyone who is either harmed or could potentially benefit is able to contribute to the process, so that as societies we can weigh those balances. And where I see the biggest problems happen is when one whole range of harms or one whole range of opportunities are left out of the conversation. And so when that happens, it seems like an obvious thing to either, put the pedal to the floor and just drive straight ahead, because it seems super clear that we're going to get so much social benefit, but then we don't have the conversation about what we're actually losing or what we might be displacing when we go forward. And so, I see the sort of next 10 years as being about trying to balance those conversations so that we can come to these sort of appropriate either compromises or structures. And, that process, I think, will be at the global level, it will be at the country level, and it will be at the regional level. We're going to see all of these processes align, and it'll happen all at once. It'll be somewhat messy, but I have hope that we will make progress over the next decade.
We are building a comprehensive land record system, and definitely we have a big data set of 0.75 million in the country. So building AI solutions around that, integrating and then providing a personalized services to the farmer definitely is one thing where AI can be used in big way in maintaining land records in the country.
I believe in the adoption of AI also, there are bound to be winners and potential losers also. So one has to be very mindful of the fact that as this journey unfolds, we have to be inclusive to the extent possible in terms of taking everyone along, making AI and the data that is coming, that is getting generated, making it available for as a public good, building solutions that are aiming the bottom of the pyramid, and also at the same time, not as a question of control, but to a certain amount having some kind of regulation or at least parameters around and checks and balances around the developments that are happening, so that they're put to stringent tests, that there is no bias that is getting built in, and the solutions that are being delivered are for the greater good.
Sir, with this, we have come to the end of this wonderful session. So today's session has been extremely informative and it is indeed very inspiring to see that great work being done by various countries. We have seen some of the wonderful case studies discussed today by different panelists. I would like to thank my boss, Mr. Abhishek Singh, who couldn't join because he was called by Honorable Minister, for his constant support and guidance. Extremely thankful to Mr. Saurabh Gaur, Joint Secretary, who is leading India's efforts in implementation of AI in the country. A warm thanks to all the distinguished panelists today, highlighting the work being done by them in their countries. Mr. Jia Khan, Professor Eric, Mr. Evan, Dr. Rena, for the wonderful insight into their work. And many thanks to Mr. Damanand Jha, Banali Mukherjee and the team at NEGD for organizing this AI Pe Charcha. And we have been organizing these type of episodes after RAISE, as we have spoken earlier, and hope to see that these type of e-meets continued in the future also, and we hope that we will be sharing a lot of experiences later on. Thank you all for, especially the audience, for joining us in today's session. With this, I again thank everyone for joining. Thank you so much.